Hello everyone, welcome to Site Programming channel. I am Radhika, belongs to the Department of Information Technology from Session Institute of Technology and Engineering. I am submitting the video assignment on Hamiltonian cycle using backtracking technique under the supervision of the lecturer, sir. Hamiltonian cycle using backtracking technique. Before going to the problem, let us discuss about what is Hamiltonian cycle. Hamiltonian path in an undirected graph, it is a path that visits each vertex exactly once. A Hamiltonian cycle, also known as Hamiltonian circuit. It is a path in a graph that visits each vertex exactly once and returns back to the starting vertex and forming a closed loop. In other words, it is a cycle that passes through every vertex of a graph exactly once. Let us discuss about what is backtracking technique. Backtracking is a general algorithmic technique used for finding all possible solutions for a given problem that involves exploring all possible paths or combinations. Let us do the problem. Find the Hamiltonian cycle in the given graph. This is the graph. Then we write the adjacency matrix for this graph. Let us discuss how we write the adjacency matrix for the given graph. If the direct edge is present between those two particular two nodes, then we write 1. If not, we write 0. For example, let us consider two nodes, let A and B. There is a direct edge is present between A and B. So we write 1. If the direct edge is not present, then we write 0. Let us go to the problem. Here this is the adjacency matrix. Here I am considering the source node as A. Here the starting vertex is also A. Let us check what are the adjacent nodes to A. Here the adjacent nodes to A are B and E. So the possible chances to move forward are A, B and E. Let us go to B. Again check what are the adjacent nodes to B. Here the adjacent nodes to B are A, C, D, E. Here A is already visited, so we are not considering them. So the possible chances to move forward are C, D, E. So we write C, D, E. Let us go to C. And again check what are the adjacent nodes to C. Here the adjacent nodes to C are B and D. Here B is already visited, so we consider only D. Then go to D. And again check what are the adjacent nodes to D. Here the adjacent nodes to D are B, C, E. Here B and C are already visited, so we consider only E. In this level, all the 5 nodes in the graph are visited. The Hamiltonian cycle tells that all the nodes are visited, then it returns back to the starting vertex. So we check whether the direct edge is present between the last vertex and the starting vertex. Here the last vertex is E and the starting vertex is A. There is a direct edge is present between A and E. So we return back to the A. This is the correct Hamiltonian cycle in the given graph. Let us check any other Hamiltonian cycle present in the given graph. So we backtrack to the previous node. Here the previous node is D. There is no possible chance to move forward. Then back to previous node. Here the previous node is C. There is also no possible chance to move forward. Again back to the previous node. Here the previous node is B. Here there is two possible chances to move forward. One is D and another one is E. Let us go to D. Again check what are the adjacent nodes to D. Here the adjacent nodes to D are B, C, E. Here B is visited, so we consider C and E. So we write C and E. Let us go to C. And again check what are the adjacent nodes to C. Here the adjacent nodes to C are B and D. Here B and D. Both two nodes are already visited. There is no possible chance to move forward. This is dead end. Again back to the previous node. Here the previous node is G. Let us go to E. I can check what are the adjacent nodes to E. Here the adjacent nodes to E are A, B, D. Here A, B, D. All the three nodes is already listed. So we are not move forward. This is a dead end. Again back to D. There is no possible chance. And again back to B. There is one possible chance to move forward. That is E. And again check what are the adjacent nodes to E. Here the adjacent nodes to E are A, B, D. Here A, B. Only two are visited. One is remaining. And again possible chance to move to D. So we write it D. Again check what are the adjacent nodes to D. Here the adjacent nodes to D are B, C, E. Here B is visited, E is also visited. So we consider only C. So we write C. In this level, all the five nodes are visited. So we check whether the edge is present between the last vertex and the starting vertex. Here the last vertex is C and the starting vertex is A. Let us check. Here 0 is present. So there is no direct edge between A and C. This is the dead end. This is not a correct Hamiltonian cycle. Then again back to D. There is no possible chance to move forward. Again back to E. There is also no possible chance to move forward. Again back to B. Here also no possible chance. Again back to A. There is one possible chance to move forward. That is to E. Let us go to E. Again check what are the adjacent nodes to E. Here the adjacent nodes to E are A, B, D. Here A is only listed. B and D are present. So we consider B and D. Let us go to B and D. Let us go to B. Again check what are the adjacent nodes to B. Here the adjacent nodes to B are A, C, D, E. Here A and E are listed. So we consider C and D. So we write C and D. Let us go to C. Again check what are the adjacent nodes to C. Here the adjacent nodes to C are B and D. Here B is only listed. So we consider D. Let us go to E. And again check what are the adjacent nodes to D. The adjacent nodes to D are B, C, E. Here B, C, E. All the three nodes are already listed, so we are not considering them. This is the dead end. Then again back to previous node C. There is no possible chance to move forward. Then again back to B. There is one possible chance to move forward, that is D. Let us go to D. Again check what are the adjacent nodes to D. Here the adjacent nodes to D are B, C, E. Here B is listed, E is listed, and C is remaining. So write to C. Here all the five nodes are visited. So we check whether the directrix is present between the last vertex and the starting vertex. Here the last vertex is C and the starting vertex is A. There is no direct edge is present between A and C. This is the dead end. This is not a correct Hamiltonian cycle. Then again back to D. There is no possible chance to move forward. Then again back to B. There is no possible chance to move forward. Then again back to E. There is one possible chance to move forward. That is D. Let us go to D. And again check what are the adjacent nodes to D. Here the adjacent nodes to D are B, C, E. B, C, E. Here E is only listed. B and C are remaining. The possible chances to move forward are B and C. So we write B and C. Let us go to C. Again check what are the adjacent nodes to C. Here the adjacent nodes to C are B and D. Here D is only listed, B is remaining. So we write B. Let us go to B and again check what are the adjacent nodes. Let us check here. All the nodes in the graph are listed. So we check the edges present between the last vertex and the starting vertex. Here last vertex is B and the starting vertex is A. Here the direct edge is present between the A and B. This is the correct Hamiltonian cycle. Then again back to B. Then again back to C. Then again back to D. There is one possible chance to move forward. This is B. And again check what are the adjacent nodes to B. The adjacent nodes to B are A, C, D, E. Here A, D, E are listed, so we consider only C. Let us go to C. And again check what are the adjacent nodes to C. Adjacent nodes to C are B and D. Here both B and D are already visited, so we are not considering them. This is the dead end. This is the complete Hamiltonian problem using backtracking technique. In this graph, we have two Hamiltonian cycles are present. Let us see what are they. One is we are starting with A, then go to B, then go to C, then go to D, then go to A, then return back to A vertex. Another one is start with A and again go to E and go to D and go to C, then go to B, return back to A. This is the two solutions. Thank you for watching. If you have any queries, write it out in the comment section.